In this video, we'll continue with our examples of definite integration. With number 15, again, we want to do some rewriting before we start. And so we begin with integral from 1 to 4. This time we're going to, what a lot of people like to do is to move that square root of u from the denominator and make that u to the negative 1/2 in the numerator times u minus 2 du, and then integral from 1 to 4. We're going to simply distribute. So u to the negative 1/2 times u to the first power, or u to the 2/2, is going to give us u to the 1/2 power. And then minus 2u to the negative 1/2 du. All right, and at that point we're ready to begin. This is number 15, by the way. We're ready to begin to find the antiderivative of that. And so the antiderivative of u to the 1/2 is u to the 3/2 divided by 3/2, or which is 2/3 u to the 3/2. And then the antiderivative of 2u to the negative 1/2 is going to be 2u to the positive 1/2 divided by 1/2, which is the same as multiplying by 2. So we're going to get minus 4u to the 1/2, and that would be from 1 to 4. All right. So now we're ready to evaluate that antiderivative at the upper limit minus evaluate it at the lower limit. And so we get at 4. Now one of the easier ways of finding 4 to the 3/2 power is to first take the root. Remember that a rational exponent is power over root, and we can either evaluate the power first or the root first. It doesn't matter. So we'll take the square root of 4, which is 2, then 2 to the 3rd power, which is 8, and so we have 2/3 times 8, which is 16/3, minus square root of 4 is 2, minus 4 times 2 is minus 8. And then that's all going to be minus 2/3 minus 4. And doing that math out gives us 2/3. All right, so very quickly I'm going to show how this works on the graphing calculator. So I put the function in, and I want to put the function in its original state, not in my rewritten state, because maybe I made a mistake when I rewrote. And so I want it in its original state, which is x minus 2 or u minus 2 divided by square root of u. And my viewing window here is going to be from -5 to +5 for x, from -2 to +5 for y's. And graphing that, we're going to get something that looks like this. And second calc, option number 7, and I want the integral from 1 to 4. And you can see there that we get 2/3. All right, so we'll go on to the next one. Number 17 also is going to require a simple rewrite. So we're going to start with the integral from -1 to +1 of the cube root of t. So that would be t to the 1/3 minus 2 dt. And we're ready to begin to find the antiderivative now. So we're going to add 1 to 1/3. That gives us t to the 4/3 divided by 4/3, which this is the same as multiplying by 3/4, and then minus 2t. And we want that antiderivative from -1 to 0. So at 0, fortunately everything becomes 0, and then minus. At -1, we want the cube root of -1, which is -1, raised to the 4th power, so that's going to give us a +1, so we're going to have 3/4, and then minus 2 times -1, which is minus a negative 2, which is going to give us a positive 2 there. And so that's 2 3/4 in the negative. So we should end up with negative 11/4. And we'll bring in the graphing calculator. And before I get to that, I can see that I made a mistake here. So I'm going to retrace my steps. My limits of integration, I was looking at number 21, the limits there. And on 17, it should be from -1 to +1. So I'm going to step back for a second. And then I'm going to erase what I put over here because it's no longer the the antiderivative evaluated at the upper limit is no longer 0. Sorry, so that upper limit should be 1. And I'm going to erase this part. And we're going to start over again. So first of all, we have 1 evaluated to the 4/3 power is just going to be 1. So we have 3/4, then minus 2, then minus 3/4, and plus 2. And working that out gives us a -4. And that's what we should have. So I'm going to bring in the graphing calculator now. And we start off with x to the 1/3 power minus 2. Now notice that I put the rational exponent in parentheses. So whenever you're doing a rational exponent on a calculator, you have to put that in parentheses. Or otherwise, the order of operations will do x to the 1st power and then take that result and divide it by 3. So we want it to be x to the 1/3 power. Alright, so that's the first thing. In this particular case, I'm going to set my window to go from -5 to +5 by 1. And the y values from -5 to +5 by 1 also. And so when I go ahead to graph, well, you can see the value there again. If you want to clear that, we're going to do second, program, option 1, clear draw, and it will clear the shading and re-plot the function there. Alright, so that's the function, and then we want to find the integral from -1. Alright, first of all, second calc, option 7, integral from -1 to +1, and we get -4 there. So that takes care of that. We'll go on to the next problem. Alright, for problem number 19, we also are going to do some rewriting here. But I think the easiest way to do this would simply be to pull out the 1/3 as a constant multiple. So we're going to use the constant multiple rule here. Bring out the 1/3 from 0 to 1. And that just leaves x minus square root of x, which is x to the 1/2 power dx. Alright, so we're going to leave that 1/3 out there, and in the end we're going to multiply everything by 1/3. So the antiderivative of x is going to be x squared over 2. The antiderivative of x to the 1/2 is x to the 3/2 divided by 3/2, which is the same as multiplying x to the 3/2 times 2/3. And here, let's make sure we get our limits correct, are 0 to 1. Alright, so the 1/3 we leave on the outside. And this one should be simpler because when I plug in 0, everything is going to zero out. It doesn't always happen that way, but fortunately in this case, plugging in 0 gives us 0. Plugging in 1 is just going to give us 1/2 minus 2/3. And when I do the arithmetic there, alright, so bringing in the graphing calculator, we have 1/3 times x minus square root of x. And my viewing window in this case is going to be x is -2 to +2 by 1s, and y's are -1 to +1 by 1s. Now, again, a lot of times you can only figure this out by tweaking it and seeing what works best. And I'm just going to show you my final product there. So when I go ahead and graph that, I'm going to get something that looks like this. It's just a little bit below the x-axis between x equals 0 and x equals 1. And I'm going to go ahead and find the antiderivative, and that is option 7. or find the integral there from 0 to positive 1, and it shades it out and gives negative 0.0556, and we can see by coming back to the main screen that negative 1 divided by 18 is just that, negative 0.055555 infinitely. Alright, so that takes care of the next problem. Alright, for number 21, we don't need to do any rewriting there. We have the integral from negative 1 to 0 of t to the 1/3 minus t to the 2/3. And finding the antiderivative, add 1 to 1/3, we get t to the 4/3 times 3/4, and t to the 2/3 is going to become t to the 5/3, so minus 3/5 t to the 5/3, and from negative 1 to 0. Fortunately, when I plug in a 0 there, that's all going to go away. We have a 0 minus, and plugging in negative 1 to t to the 4/3. So cube root of negative 1 is negative 1, but raised to the fourth power is going to give us a positive 1. So we have 3/4 there, and then minus, and negative 1 to the 5/3 is going to stay negative 1, so 3/5 times negative 1 is going to give us negative 3/4 plus 3/5. And I can see that I made another mistake here again. I have the 3/4 should be positive inside. And so we should just have negative the quantity 3/4 plus 3/5, which is negative 1.35, or negative 27 over 20. And we'll bring in the calculator now. So first we put in the function. Remember that when we have a rational exponent, we want to wrap that in parentheses. So x to the parentheses 1/3 minus x to the parentheses, or quantity 2/3. And for the viewing window, we have negative 2 to positive 2 for the x's, negative 1 to positive 1 for the y's. Actually, I'm going to change that to negative 2 to 1 for the y's. When I go to graph it, you can see we're looking for the definite integral from negative 1 to 0. And so simply second calc option number 7, negative 1 to 0. That's the upper limit. And we get negative 1.35, which is negative 27 over 20. Don't worry about the little remainder there. That just has to do with the error that the calculator introduces by not having an exact answer. It's an approximation. Now with number 23, if we can get this in here, we have an absolute value function of a linear function, and that's going to produce triangles. And so I'm going to graph that really quickly. And the way we do that is we go to Math, Number, Absolute Value. So we get absolute value of 2x minus 5, and we want that from 0 to 5. Now if I zoom standard on that, I'm going to get this triangle shape here, and I want the area from 0 to 5. Now this time I'm going to start by using the calculator, and so I do second calc option 7, 0 to 5, and you'll see what I get there is two triangular areas for a total area of 12.5. And I'm going to move the calculator out of the way, so make sure you see how that goes there. They're really two symmetrical or two congruent triangles with a total area of 12.5. And I would do this graphing by hand. First I'm going to bring out a 2 from the absolute value. And when I factor out that 2, you can see that that equals 0 when x is 5/2, or 2.5. So I put that 0 there, and I plug in x equals 0 to get 5, and I plug in x equals 5 to get 5. And I get two triangles, and you can calculate